Alright, so this is the first video in our momentum and impulse unit where we're going to talk about momentum, which we covered in class. So this is just a recap of what we talked about in class and a full solution of the problems that we went over as well. So we talked about how the things that determine the amount of momentum an object has are its mass and velocity, which gives us a definition of a product of an object's mass and velocity. So it's really not saying anything totally exciting. Its symbol is a Greek letter rho, which is basically you write it as a P, and nobody really cares much different. And its formula is m times v, and we get units that don't have any simplification of just kilogram meter per second. So it is a vector, and its direction is the same as the velocity. So those two things are the same. So let's take a look at this first example, where we have a 1 gram bug that's trying to have a momentum of 0.28 kilogram meters per second. And we need to know if this is possible based on its resulting speed. So we just set up our equation, rearrange for v by dividing by mass, plug in our numbers, and have to make sure that you put the mass into kilograms. If you leave it at grams, you're not going to get the right answer. Mass in any equation always has to be in kilograms. And we get a speed of 280 meters per second. Just for reference, the speed of sound is approximately 330 meters per second. When you're traveling at about 115 kilometers an hour, that's only 32 or so meters per second. So it is, although possible logically, reality is it's probably not possible that this bug can actually go that fast. That is just a ridiculous kind of speed for a little bug, even though they do fly very fast. So let's look at this second example. Mass, we've got a compact car with a mass of 725 kilograms and is moving at 115 kilometers toward the east. Determine the magnitude and direction of its momentum. Okay, easy enough. And mass, we're given the velocity in kilometers an hour. We don't like kilometers an hour. We want to use meters per second always. So we have to convert that, divide it by 3.6, and you get 31.944444 meters per second to the east. So then we just set up our equation, and we're just going to plug in numbers. This is a very plug and chug type of equation. There isn't a lot of rearranging that we have to do to make this work. And we get a final momentum that our calculator tells us as 23159.72 kilogram meters per second east. And we're going to have 3 sig figs, so we're going to have to go into scientific notation. 2.32 times 10 to the 4 kilogram meter per second. And that's direct east in our momentum. Part B asks us if a second car with a mass significantly higher of 2,175 kilograms has the same momentum, what is its velocity? So we use the same momentum. Now I'm just going to write out the sig fig answer because it's much easier to write out, but your calculation should use the unrounded answer out of your calculator. So again, start with our equation, isolate for velocity by dividing by mass, and again, just writing out the simpler one, because it is just much less to write out. And divide that by 2,175 kilograms. And your calculator should tell you 10.64814.815 meters per second east, which to proper sig figs would be 10.6 meters per second. And that must be east. So that's just a few examples of how to calculate momentum, where we're, or using the equation to relate momentum and mass and velocity. So we went over a bunch of examples, and the next topic is impulse, and then we're going to connect impulse to momentum by using the impulse momentum theorem. So this is momentum, and the next video is on impulse. And as always, physics is awesome.